My name is Semra Çoman from Boğaziçi University. I'm a faculty member at Boğaziçi University Istanbul, and two of my colleagues for this study is here, Carrie and Anne, and I would like to acknowledge three other colleagues, John Taylor from Georgia Tech, and from Virginia Tech, Trip Sheely, and Josh Iro. Sorry. Okay, my outline for today's presentation, I will start with our motivation for this study. I will briefly go over the background. Then I will state our propositions. I will talk about our methodology, findings, contributions, and potential future research areas. Okay, sorry. So why do we need virtual project teams? As in all other industries, construction industry is also heavily affected by the globalization. Nowadays, we have projects located in developing countries, for example, and they need prompt, very cheap infrastructure, for example, solutions for their problems. And in the developed countries, we have so many construction companies who may answer those needs. And obviously, it's a competitive industry, so they need to mitigate their costs. How can they do that? They can outsource their design and service work. So they may get their service, for example, design services from Europe, from India, and they may contact with several suppliers from China. So which brings us to a very global networks team, actually. And since it may not be all the time possible to collaborate co-locatedly, and with the advantages of the developing technologies, we form actually virtual project teams. Let's go into the deeper understanding of virtual project teams. Changing organizational structures in order to meet the demands of the fast-paced and dynamic global economy, meaning that nowadays we don't actually use the traditional managerial settings, structures. Instead, we form more collaborative and more network structures. And the introduction of the information and communication technologies, as we discussed in the previous presentations, they actually make it easier to collaborate over the boundaries of time, location, and the culture. So our research objective in this sense is to examine different collaboration approaches developed in multinational virtual project teams throughout the organizational and 4D modeling of a construction project, and compare them with single nationality virtual project teams. So our starting point is actually, we believe that there is a significant difference between the collaboration approaches of the multinational versus single national project teams because of the cultural diversity and the linguistic diversity that those two teams have, two types of teams have. So hopefully with this study we develop a more robust understanding of the multinational project teams that carry out global construction projects. So the features of multinational project teams, they offer flexibility and to be able to remain competitive in this market. According to Di Stefano and Masnevsky, there are three types of global teams: the creators, the destroyers, and the equalizers. Obviously, the most successful ones are the creators, because those teams actually, they recognize the diversity and they benefit out of their diversity. The destroyers, unfortunately, they take that diversity as a drawback, and it creates lots of tension and conflict among the group members, and because of this reason, their performance is lower. And the equalizers, they do not recognize the advantages of having the diversity. However, if you bring people from different backgrounds, it is actually a ground for increasing the creativity to find more and different solutions to the problems. So Di Stefano and Masnevsky look at those creator global teams, and they recognize that they use actually this MBI method, which is mapping, bridging, and integrating model. Basically, they recognize the difference, they communicate those differences, and then they implement into their solution. So the negative aspect of diversity can be reduced by appropriate communication media according to Staples and Zhao, meaning that if you provide enough communication technologies, sufficient communication technologies, then it makes it easier for the global teams to communicate and to share their different perspectives. All those previous studies shows that the role of the technology is significant in the global teams. So rapidly developing communication systems actually facilitate the information transfer in the global teams. And according to Carrie and her colleagues, evolving project information formats such as the building information modeling format, for example, it also makes it easier to transfer explicit knowledge. And we know that also with the messy talks, it is also easier to transfer the tacit knowledge. So here's an example of our platform CyberGrid that we use for the experiments. We use a virtual world actually, which is proved that it can be successfully used for the collaboration environment for the designers, since it increases the communication and the awareness, especially the spatial awareness. Multinational teams display in our project, display and transfer project information through boundary spanning visualization technologies. So we name those 3D models and shared screens, or the team models in our project, called boundary spanning visualization technologies. So which brings us to our propositions. The first one, multinational virtual project teams utilize boundary spanning visualization technologies more frequently than the single nationality when executing spatially rich tasks. And the second one is the effective boundary spanning visualization technology is positively correlated with the cohesive collaboration. And according to the literature, we know that there is a strong correlation between the cohesive networks and their high performance. So we can actually conclude that if global teams can utilize effectively those boundary spanning technologies, we actually end up having a higher performing global virtual teams. So to be able to test those arguments, we developed two types of networks, the domestic networks and the global networks. And in each team, we had scheduling team and 4D modeling team. Scheduling team was the students of the Columbia University, and 4D modeling team were the students of the University of Washington Seattle, sorry. And we had also I was the research assistant back in that time. I was the facilitator, and Anne was also the facilitator, right? We were the facilitators, and we provided the technology support and helped them to benefit their diversity. And we had two different types of boundary spanning visualization technologies, the team model and the 3D models embedded in the virtual environment that you can see on the pictures at the right-hand side. So you see our students, and we have the 3D model, a scale 3 model, which is the green. They have those team walls on the left and right-hand side where they project their presentations or their models or whatever document that they would like to share. And the picture underneath shows the actual size 3D models where with their avatars they can go through those 3D models and to inside the real environment, which increases the spatial awareness. So we collected data in the second version of the CyberGrid, which was developed based in Unity, one of the famous game engines. We actually collected data for 8 weeks, but for this study we only focused on the 4 weeks. The scheduling week, 4D modeling week, and the first intervention and the second intervention weeks, because only those 4 weeks actually include the tasks that we are interested in. The first 2 weeks are the ice-breaking activities and letting students explore the environment and get to know each other. And the last 2 weeks actually for developing the reports and the presentation. This is again, as in the previous presentation, this was a course actually conducted at Columbia University and University of Washington, Seattle. And then, since all the interactions were recorded, we had to quantify. For that, we transcribed the data by using Elan. So we coded each speaker and the addressee. So Elan is a very useful software because it's in the tier structure. So you can very easily code the speaker, addressee, and what they're talking about, and whether they are using one of the boundary spanning technologies or not. So we use actually bidirectional interaction for both members. So it means that for example, if I'm talking to carrier by showing by using one of the boundary spanning virtual technologies, then I code it myself at the speaker, and the addressee is the carrier through the BS VTs. So in total of 18,680 interactions were coded, almost equal, over 10,000 were in the multinational teams, and almost 8,000 of them were in the single nationality teams. So for the data analysis, unfortunately, since our networks were really small, we couldn't conduct very dense social network analysis. We only calculated the density of each network, which shows their cohesiveness, and to be able to compare the correlation between the usage of boundary spanning technologies and the densities, we use a simple t-test. So let me show you the results. Actually, these are the percentages in this table. We see the use of boundary spanning visualization technologies as a percentage of all interactions. I think this graph is more meaningful. In this graph, we see both the direct communications, meaning that they do not get the advantage of the boundary spanning technologies, so they directly speak to each other. But the top one is showing when they are communicating or collaborating, they actually get the advantage of those technologies. It is interesting that the starting point for both the single nationality and the multinationality teams are the same. However, there's a significant difference in 4D modeling week, meaning that the 4D modeling is, as you all know, it is bringing the 3D models and the scheduling models together, and they form through the Navisworks a 4D model. So multinational team utilize those models much more frequently than the single nationality teams. And here we see the use of boundary spanning visualization technologies percentages for each type of network and for each week. And we also calculate the network densities by using UCINet. And the correlation coefficient is 0.74 with a significant p-value of 0.002. It means that there is a significant correlation between the usage of boundary spanning visualization technologies and the network densities. So what's our contribution? So according to Di Stefano and Masnevsky, and following their studies, Carta and Shidambram, they actually put out that we need to support technologically the global teams. But in our study, we went one step further, and now we are looking at the virtual teams, global teams collaborating in virtual workspaces. So we actually need to, since they do not see each other, we need to provide even more boundary spanning technologies, and this is actually also validated through our students, because at the end of each semester we ask our students in which way we can improve the cyber grid, and they have really creative ideas, and each year they recommend us to improve by providing more boundary spanning virtual technologies. I'm done. So the limitations are, unfortunately, we had limited number of students in each network, so we do not have large network size. We aim to have larger network size. We would like to replicate these studies with the industry participants. Many studies show that there is this, many studies show that students and expert engineers could achieve similar results, but anyway, we would like to validate that. And we would like to compare face-to-face versus virtual project networks to be able to observe, basically to be able to isolate the impact of the diversity. Thank you very much for your attention, and I would like to take questions if you have any.
We only have time for one question.